Okay, so we're going to continue on today with our related rates. So example 5 is going to be another Pythagorean theorem question. There's a bit of a review from last day. So let's take a look at the question here. So we've got a 20-foot ladder is propped up against the side of a house and it's not properly secured. So that's why we were going to have that rate of change, because something's going to move. So it causes the bottom of the ladder to slide away from the house at a constant rate of 2 feet per second. How quickly is the top of the ladder falling? At the exact moment when the base of the ladder is 12 feet away from the house. Okay, so if we draw ourselves a little diagram here, and if we fill in the information, so we should assume and always assume that the house and the ground meet at 90-degree angles. Hopefully that is correct in any build. We have a 20-foot ladder, so I'll label that side C. Okay, and it's propped up against the house, so it has the bottom of the ladder sliding away from the house at a constant rate of 2 feet per second. So if I label these sides A and B, and if you remember from last day, we also have these rates of change. So the derivative of A with respect to time, derivative of B with respect to time, and the derivative of C with respect to time. Okay, so going to this question now, the bottom of the ladder, so here's our base, is the bottom, is sliding away from the house, so it's going outwards at a constant rate of 2 feet per second. Again, watch the units. Rate per, a length per time is going to be this value right here. How quickly is the top of the ladder falling? So when we talk about a rate, we've got to be talking about this, because we're talking about how quickly is that ladder coming down the wall at the exact moment when the base is 12 feet. So again, our base is B, so we've got this. Any questions about the setup? Okay. Again, because it's a right triangle, we're going to use the Pythagorean theorem. So a squared plus b squared is equal to c squared. If we take the derivative, like we did last class, what we end up with is 2a times the derivative of a with respect to time, plus 2b times the derivative of b with respect to time is equal to 2c times the derivative of c with respect to time. Okay. Now what I didn't do with you the other day is all of these terms, because it is an equation, divide by 2, so you can make that easier for yourself just to reduce the numbers. Okay, so like we ended off last class, we have 6 unknowns. How many are given to us? When we completed the diagram, how many are there? Okay, so we have 4. That's what you guys are seeing is 4. So the problem is this is the one we're trying to find, but we don't know A and we don't know the derivative of C with respect to time. So here's what I mentioned to you guys yesterday. If we have a ladder, and this is what happens, if we have a ladder that's going down and just sliding away from the wall, the length of the ladder, that certain distance of the ladder, is not going to change unless something broke inside and the ladder collapsed in itself. So what you have to remember about these then is if there's no change here, this rate of change is 0 feet per second. Okay, and that's just to indicate that the ladder length is not changing. It's still going to be 20 feet when it hits the ground. Okay, any questions? So it leaves us now 4 of the 6 is where we're at now. So we need to still find A. And to find a length, remember, to find a length, you're going to use Pythagorean. So we're just going to use our basic a squared plus b squared is equal to c squared. We do know b and c. So a squared plus 12 squared is equal to 20 squared. 20 squared is 256 minus the 144, which is 12 squared. So a squared is going to be 256. Sorry if I said that wrong. 20 squared is 400 minus the 144. And then take the square root of this. In this case, again, when we're not worrying about the positive negative root because we're talking about lengths. So the square root of 256 is going to be 16. So that fills in one more piece of information. Okay, questions from you? Okay, so now we've got our information. We're going to plug in and solve. So we've got 16 times the derivative of a with respect to time plus 12 times 2. And again, if you want to put your units in here, be welcome to do that. And 20 times 0. So the nice thing about this is 20 times 0 is still going to be 0 on this side. 12 times 2 is 24, so we'll subtract that to the other side. So we have 16 times the derivative of a with respect to time is equal to negative 24. Dividing by 16. The derivative of a with respect to time is equal to negative 1.5, and this is in feet per second. Any questions? Who can tell me why the answer is negative? Justin? Because the ladder's falling. So what happens here is this distance, that is whatever distance it starts off with, once this ladder is sliding, that distance is going to be less and less each time. And so that's why we see that negative, because it's coming closer to the ground. Please remember to include your statements. So therefore, when the ladder is, where were we, 12 feet from the base of the wall, the top is falling at a rate of 1.5 feet per second. And again, as I've said to you previously, when we talk about that negative, we're not going to include that with the number. We're going to include that as that expression. So whether it's falling or it's decreasing, right? But in this case, the top of the ladder is falling at that rate. Any last questions? All right. So next example here, this takes us into a new category. So far we've dealt with the area volume type questions, perimeter area type questions. We've also done Pythagorean theorem questions, so anything that creates a right triangle, we've got Pythagorean theorem. Now we have this cone shape. So this will be something, in this case we're looking at a water tank, but similar to this, they'll talk about a vase, so kind of a, or even those little paper cups at water fountains, if you've seen those little triangular cone-shaped cups. Also, for you that are on the farm and you run out of bin space, if you're augering it on the ground, what you have is an inverted cone, right? So the base is wider, and then your grain is usually peaking more in kind of a cone shape. So those type of questions fall into this category. And they're all dealt with in the same way. So whether it's inverted or right side up, they're going to have that same effect. Okay? So water tank is built in the shape of a circular cone. So let's draw this out. So a cone shape, we've got this. All right. So what we know is that at the start of this, we have a height of 5 meters. And it has a diameter at the top. Now the key thing about this, these questions, watch if they give you diameter or radius. We're going to use radius. So if the diameter is 6, this radius from here to here is going to be 3 meters.